Hello everyone, my name is Pamela Marchant, and together with Felipe Zurita, we will guide you through this journey to La Silla Observatory. Please be welcome, and let's meet each other. First, I am I would say soon to be PhD student in astronomy, and I really like galaxies, but I know a lot of astronomy, and I work since 2017 in the Silla Observatory, so I know a lot of things about the observatory itself and astronomy. So any questions you have, you can ask us. Also, we have Surita. So, hi, Surita. Hi, Felipe.
Hi Pamela. Hi everyone. I'm the producer. Every Saturday, I stay here showing the Observatory La Silla, Paranal, everything you know about the ESO or astronomy. So hi Pamela. How are you?
Very, very good. It's nice weather outside.
Yes.
Let's say that all your questions you can leave in the comment section, and Felipe is going to be reading of those, and then at some times of the tour we will read those questions and answer them. So be free to ask us anything.
We give a space for questions about anything you want to know about the ESO, the astronomy, the telescope, or for the guide of La Silla. Okay, let's start, Pame.
Okay. So let's begin with about ESO and what is ESO. Let's wait for the picture. ESO, as the name it says, European Southern Observatory. It's an organization that comprises 16 member states. From you can see on the screen, Denmark, United Kingdom, France, Sweden, Italy, for example. So leave in the comment section where are you watching us and if you are part of one of these countries. And also you can see Australia in the we have someone from Amsterdam. Let's see in the Australia. We can see at the bottom right part of the screen. Australia is an strategic member, so it's not an European state, but it's part of ESO. And also we have Chile in the left bottom corner. And Chile is not part of ESO itself, but is the host state. It means that all ESO observatories will be built in Chilean territory. But what are those observatories? So let's change the picture. And we have here Chile, and in the northern part of Chile we have a zone that comprises 3 regions. First, we have Paranal Observatory, where we have the left up part of the picture. And Paranal is the current most technology and big telescope, optical telescope right now. And we have the BLT and the BLTI, because these 4 telescopes can work together as one big telescope. Then we have VST and VISTA. I really like VISTA telescope, even though they are not as big as the BLT, but my thesis and I work with VISTA telescope, and it's so amazing the kind of research that they can do. And then next to Paranal, we have Armazones, that it will be or is now being built, the ELT telescope, the Future Extremely Large Telescope, that is in front of Paranal. This telescope will have nearly 40 meters of diameter, the primary mirror, that is so huge. Then we go more to the Andes mountain range. We get the Chacnantor Plateau, which is the ALMA telescope and APEX. ALMA is an array of radio telescopes. We have like 66 radio telescope like the one that you can see on the picture, and is so high, like 5,000 meters above the sea level. And finally, but not more important, we have La Silla Observatory. And this is the observatory that we will be visiting today. And I forgot to mention the CESO, that because we have the banner for the questions, but will soon to be built to observe all of the Cherenkov. It's a Cherenkov telescope array to observe gamma ray. So now let's travel to La Silla Observatory.
Yes, we will start to move to the observatory with this special video out of the Earth.
So let's start our journey from Europe. We can see. Sorry, I have a cat and it's bothering me right now. Okay, so let's start our journey from Europe. You can see those countries outlined in white are the member states of ESO. So as we travel through the ocean, let's talk about the mission of ESO, and is to build and to know what kind of research we will need in the future. So they work together with astronomers so to think invent actually how will be all of the telescope and to build those telescopes as the astronomer needs to make all of their research. So a lot of technology, science, and other kind of works or jobs working in ESO. So we're getting to Chile. You can see the Atacama Desert, and it's so brown because it's the driest desert in the world. And right now, you can see at the top of the mountain a little buildings. Those are the telescopes of La Silla Observatory. And it's the first observatory of ESO here in Chile. Okay, so right now we can see a flight over the observatory, and we have a lot of tiny telescope, or tiny no, but a meter diameter of telescope. For example, in the screen you can see the Danish telescope. These are the extra telescope that are so tiny to observe for for exoplanets. I'm sorry. This is ESO 2.2 telescope that is from Max Planck Institute, a 1 meter telescope. But now, at the top of the mountain, you will see two big telescopes. First, the entity that is shown in the screen right now. It has an equal shape. It's like an octagonal shape. Then we have the CEST that is in the right part, and this is like the grandfather of ALMA. It's a radio telescope. And then at the top of the mountain, the most highest place of La Silla, we have the 3.6 telescope. These are the three main telescopes that we visit during the how I'd say the personal visits to La Silla Observatory.
Is one viewer asked if there are tours to the observatory for public. Yes, you can visit this observatory in public. Every Saturday in Chile, you can visit the La Silla Observatory or Paraná Observatory. And
Mm-hmm.
in the page of ESO.org, you can um, reserve the one space to visit these beautiful observatories. So check out in the ESO.org in the public visits.
So there's another viewer that say was there during the solar eclipse in 2019. Let's show it in the screen. I want to show that because let's change the screen. Okay. So now we are at La Silla Observatory, and in this exact place um, uh, almost like 1,000 people gathered in this park to see the solar eclipse back in 2019. So I was we were also there. So hi.
Yes, we were there in the a beautiful eclipse in this place, magical place.
Yes, so let's start with the CEST telescope. And as the name says, it means Swedish ESO sub-millimeter telescope, and it's the grandfather of ALMA because it's the first radio telescope put in the southern hemisphere, and they tested how it was working in these kind of places. But then they moved it to Alma and put Apex, and it's the best place in Earth, so they built Alma. Then we have this is the west. Um, you can see like an ocean, but it's not an ocean. It's actually an ocean of clouds because we are 2,400 meters above the sea level, and this kind of view is unusual because most of the time we have clear skies, not so cloudy as this one. And then we have the two main telescopes that we will be visiting today, and also in the present and the tour inside the telescope. So let's enter first the ESO 3.6 telescope. This telescope it was inaugurated in 1977 and is the usual like all-time telescope. We have a cylinder and a dome at the top of that. But once we enter the telescope, there's something that is so amazing for me, and this is my favorite part of the tour because I don't know if you can see someone over here. Over here, you can see a person, and it's so tiny next to the telescope's body. We say this is the telescope's body because it has all of the mirrors, and it's so big inside the telescope. But how this telescope works? First, we have the mountain. The mount. I'm sorry. We have this is an equatorial mount, and we have the dark blue part that is always pointing to the south celestial pole. But what is this point? It's an imaginary point that is always pointing to the south celestial point. So if we go to the south pole and make a projection in the sky, we have the celestial pole. And also with the northern pole, we make the projection and we have the north celestial pole. So it's always pointing to that point because when we have the planet rotating, all of the stars and the objects will be rotating around that point. So it makes easier in the old times to follow one object during the night. And then we have the light blue part that will be inclinating 90 degrees to reach the object. I think we have a video that
Yeah,
shows in an easier way.
exactly. I have a video of movement. The zone inside of the movement of the telescope is too much, but it's old telescope.
Yes. So then you already saw how it moves, but these moves need to be correlated with this part of that opens in the dome. So the dome will rotating in 360 degrees to reach the object. The name of this kind of mount is an equatorial mount because it moves in the equatorial coordinates that the astronomer use. But in the new kind of telescope, we don't use this mount anymore because we have better technologies. And this mount makes necessary for the telescope to be even bigger than the 3.6 telescope. We will see that later with the next telescope because the next telescope it calls new technology telescope. That means a lot of new technologies are applied in there. But like all times, we have this one. But how the telescope works, not for the moment. So we have the light that comes from the sky during the night. Let's say a star. The light of this star will go through this part and will be reflected on the primary mirror. The primary mirror is in this part of the telescope. Then will reflect on this part, go to the secondary mirror at this inside this black cylinder, and you can see in the right part a picture from above the telescope, and then the light will be reflect on the secondary mirror and go through a hole that the primary mirror has in the middle. So all of the light and information is gathered in this part and will be sent to the instrument that is in the room below the telescope. In the picture from the top of the dome, you can see that we have a camera or an instrument above the secondary mirror. But in the old times, the astronomer needed to be in this part inside the cylinder. So when the telescope inclinates, the telescope inclinated with the telescope, and it needed to stay during all night. Thanks to the technology, we don't use that kind of telescope anymore. So we go to another building where is the control room to make observation and in a warm space. But also you can see a series of tabs over here that these tabs will be open during the night, but they are closed during the day to maintain moisturize and clean the telescope, clean the mirror. But why the mirror is so important? Because the mirror in this telescope is 3.6 meters of diameter. A diameter is the line from one point to the biggest line from one point to another point in a circle. And why this telescope? The name of this telescope is the same as the mirror, because the light in astronomy means everything. With the light of an object, you can see the type of the object, the temperature, the color of the object. You can, with another analysis, you can get the elements of this kind of object. So if there is an old star or a new star, or of what kind of galaxy it is, for example. So also you can see if the object is coming closer to us or going farther away from us. The the age of the object and a lot of things. But if we have a tiny telescope, we can't collect too much light. But with a bigger telescope, we will collect more light each time. So more light will mean that we can detect faintest objects in the sky, and that means also objects that are very, very far away from us, like in the beginning of the universe that we want to try to see with the future ELT, for example. So this is important. And some other important numbers of this telescope that we will compare it to the next one is the weight of the primary mirror. So how much do you think that a mirror of make of I don't remember the product ceramica in Spanish.
Ceramic?
It's not ceramic. I don't remember the word in English. But how much do you think it weighs? Only the primary mirror. It has a weight of 11 tons. That's a lot, and that's like two big African elephants. But also the thickness of the primary mirror has 53 centimeters. So that's a lot. And there is another important thing in this telescope, that is the instrument. The instrument, let's show the video, please.
Let me hear.
So we have the instrument, the HARPS and the NIRPS instruments. HARPS means high accuracy radial velocity planet searcher. So it means that this telescope only looks for exoplanets. An exoplanet is a planet that is outside our solar system. And how we can do that? We have a star, and this star will have a planet rotating to that. So we have all of the gravity that make together this star system. So the planets have a little of interaction with the star and make it to move around the center of mass. But we can't see this movement itself, so we get the spectrum of the star. And we have the spectra is this rainbow over at the bottom of the video, and each line in the spectra are absorption lines. That means different elements of the object. So when these objects go to the red part of the spectra, it means that the star is going farther away from us. But if the movement, if the black lines go to the bluer part, it means that the star is coming closer to us, as you can see in the video. Next to that, we also have the NIRPS instrument. That means the same, but in the near infrared part of the wavelength. And together we get a better knowledge about the system. But we can know, we can see the telescope. I mean, the telescope, the planet. We only can know if this star has at least one planet. And then the astronomer needs to go to another telescope to know how many planets this star has. I don't know if we have any question yet.
Let me see. Nothing about no, only readings for different countries: Slovakia, Mexico, England, Colombia, Sweden, Amsterdam, different part of the world, but nothing asks about the telescope. Uh, but to people serious, I invite you to leave questions about the telescope, the visit, or astronomy, everything you need to want about astronomy, the investigation. Soon we will be show you a top 10, but we go to the next step, right?
Yes. So let's go outside and let's enter the NCT telescope. But first, you can see the difference in the shapes of the telescope. First, we have in the previous one a cylinder and the dome, semisphere at the top. But if you look closely to the entity, you can see more like rectangular shape. So let's go from this part. When you come to the Silla Observatory and we enter the telescope, we will enter from this part. Go, you can see this part, but I really like to begin the part of the tour in the other part of the telescope. So first, as you can see, the telescope's body is totally attached to the building, and you can see here the primary mirror and actually the reflection of in the primary mirror. So one of the first technologies that we have is the type of mount. The type of the mount is not an equatorial. It is known as a alpha-azimuthal mount. It means that this part of the telescope will be inclinating in 90 degrees, that we call it altitude. And if we go to the other part of the telescope, you can see in this part, look very closely, a circular shape, because this is the limit of the telescope, and in this case is the entire building, the one that rotates in 360 degrees. And that movement, we call it the azimuth. It's a very smooth and makes no sound movement, so it's perfect for observations. Let's go back on the other side. And also, Another technology, the kind of dome, is an octagonal shape. And as you can see, is totally the telescope's body is totally exposed to the sky. So all of this is the part that opens during the night of observation. And it works like the same. We have the light that comes from the sky, go to the primary mirror over here, then goes to the secondary mirror that is also in this black cylinder, and then reflect on that. But we have a third mirror inside this part of the of the building, and this third mirror is a plane mirror that will incline in 45 degrees to send all of the information to the room that is in this part of or the room that is behind this door. So in each room we have different instruments. One for optical part in this side, and one for infrared part of the wavelength. And actually, I don't know much about this one because it's not anymore the instrument. It's about they will change it, so I can't tell you more about it. So let's go to the other part of the building, and we can see some windows over here. And these windows are also to to make the inside the telescope more suitable for observations. Because if we have too many differences between the temperature inside the telescope and outside the telescope, we will have turbulence, and this turbulence will damage the image. But the primary mirror, these are important numbers. It has 3.58 centimeter, 3.58 meters of diameter. It means almost 2 centimeters of difference with the other one. But it's so different because we have a door, so a person will be of this height approximately, and it's not so tiny next to the telescope. So this is one of the also the technologies of to the other one. The weight of this telescope is only 6 tons. This is one like just one big elephant, and the thickness of the primary mirror is only 26 centimeters. It's like the half of the other one, and it's made of another material. We call it cerodure. But the reflective coat of the mirror is made of aluminum, of all of the telescope in la Silla. And this coat, we make the a full maintenance. So every 2 years, 2 to 3 years, they take off all of the reflective coat and put another one. They need to to clean the structure first, and then they put another coat of aluminum to make the mirror reflective again. But we also made a soft maintenance like every once a month. I'm sorry, and they just put a CO2 and maintain clean the telescope. So I don't know if we have any questions, but
Um, I have I have a question about the people work inside of the telescope. Where
okay.
is
Where is the people? Where do they work?
yes,
Well,
where I don't see any people inside of this telescope.
yeah, because as I already said before, the astronomer works in another building that we call it the control room. In the control room, they control the telescope. I think we have a video that we can show you.
Yes, I can. I have a video in of the control room. Let me show you. This is
So, as you can see in the control room, we have a lot of computers, and there's a lot of people working on. And in this video, we can divide in the left and the right part. In the right part are all of the computers that works with the 3.6 telescope, the first one in the tour, and in the left part of the video, we have all of the computers that monitor and control the entity telescope. So we have, for example, in the entity telescope, we have people with colored charts that are the astronomers, and they are working together. But in the more left part, you can see the operator of the telescope, and he's monitoring the mirrors, the movement of the telescope. And I forgot to mention something in the entity telescope that, and actually is one of the most important technologies, and we call it the active optics. So because the mirror is so flexible, when we incline the telescope, the gravity will work different on each part of the mirror, so we'll change the shape. And the operator right now is in the computer that controls these active optics. And we have a lot of actuators. There are like 77 actuators below the primary mirror to maintain the shape of the mirror. And also they need to monitor if there is a clear sky, because if we have clouds, the telescope won't be open. And in the right part, we also have the 3.6 telescope computers, and we have an astronomer working during the night, an operator that's go to the telescope and then go back to the coffee room, I think. And it's much better location. But how the astronomer can get here, they need to make a proposal. And in this proposal, they need to mention what kind of research they are doing, which object they want to observe, and at which time of the year they want the observations, because not all of the objects we can see it during the all nights of the year. And for example, if this object at this time of the year is too close to the moon, we will need a new moon for night, for example. So they send the proposal to international committee, and the committee will decide if you win a night or not. And only the 20% of nights of proposal gain a night of observation in this observatory. And for the Chilean astronomer, they send to the international committee, but the 10% of the night of 1 year are only for Chilean astronomer. And this is this is why, or how the ESO pay for this, to put all of the observatories in Chile.
About the investigations in the control rooms or in the observatories, I have a video about the top 10 of the discoveries of ESO. So let me show you a little bit about the top 10, the principles, the greater investigation discovered in ESO telescope and observatories.
Observations with ESO telescopes have led to many breakthroughs in astronomy, and over the years have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Well, this is the top 10 of the principal discovery for ESO, but the science continually discover new things, and I show you the ESO.org. This is the European Southern Observatory page of principal page of the in different language you need to know. I have a recent discovery of the brighter and faster growing. Astronomers identified record-breaking quasar. The quasar, the bigger bright object in the sky and in the universe. Using the BLT telescope of ESO, astronomers have characterized a bright quasar, finding it to be not only the bright of its skin, but also the most luminous object ever observed. Quasars, as the bright, are the bright cores of distant galaxies and are powered by the supermassive black holes. The black hole is the record breaker quasar is growing in mass, be the equivalent of one sun per day. The black hole growing a lot every day, making it the fastest growing black hole the date. This is the one of the recent discoveries, but you have a lot of different discover you can find, or you find about the visits the La Silla or Paranal, visit La Silla or visit to Paranal to reserve one day to visit ESO. The other thing you can send image everything you want about the telescopes, the observatories, or pictures if you know the one about the space of the observatories. Or if you need to find work to work here, you can find too. So I invite you to visit the ESO.org. So we have a special part of the that visit is in during the night, right, Pame?
Yes. We have I really like to say like bonus track because we doesn't have the chance to be during the night in the observatory. But thanks to the technology and this virtual tour, you can see how beautiful is the night sky here at La Silla Observatory. And first, we
Sorry, Pame, I have a I don't see this. I have a little question about the entity.
okay.
This is alt azimuth, so the image field of the view of the telescope will rotate the the half of the half circle degree from rise to set. So how you correct that during long exposure? How to correct the movement of the telescope? The question.
Yeah, that's right. Because the problem with alta-simultaneous mounts is that when you are observing one object in the sky and you are moving the telescope together with the object, the image will be rotating in 180 degrees. Back in the old days, we only used the equatorial mount because in this kind of mount, this movement we doesn't it doesn't happen. The object stayed without it doesn't move with the movement of the telescope. But with the alta-simultan, we have a lot of technology that help us to maintain the object at one place. Let's say for in that case, during long exposure, it doesn't matter because um, we will have the technology that to make like the camera correct that rotation that we have in the telescope. I don't know how to explain it more easy, but it's
Um,
like with computers.
they also have different programs for correcting different part of the telescope. One part of correcting the image is for movement, for camera, for transmission to the server. Have a different correct image. So it's in short words, is a program do the correct the correct image. So this is the the only question I have. And what have here is night, right?
Yeah. Yeah. So like I was saying, thanks to the technology and the virtual tours, we get the opportunity to see how the night sky is in La Silla Observatory. And we went outside from the entity telescope, and in this part you can see the octagonal shape, and so it's so different of the other one. And you can see that the roof is open because they are observing. So let's start with some of constellations. And I know that for all of the people in the northern hemisphere, the most common constellation and the most famous one is the Big Dipper. But we can't see the Big Dipper from the southern hemisphere because it's so close to the North Celestial Pole. And in this case, for example, we can see the Orions. It's one of the easiest one to find in the southern hemisphere because it's the famous Orion, the the giant hunter that we have. First, the Orion's belt with these 3 stars, but here in Chile we call it las Tres Marías. With this star, the Mintaka, Milnaram, y Al-Nitak. I don't know how I hope to pronounce those stars. And then we have this red star over here, this red giant star that is known as Betelgeuse, and it was so famous back in 2019 because it was dimming, so the astronomers and the community thought that this star will it was going to explode into a supernova.
Soon.
We know that this star will become a supernova, but not so soon. It can happen from today to 100 years ago, more, 100 years more. So next to Betelgeuse, we have this star that calls Bellatrix. I really like the name Bellatrix from Harry Potter, for example, but this is the name of my cat. So I really like this one. And then we have Rigel and Scythe. Rigel is the other bright star in Orion. Betelgeuse, Rigel, Scythe, Bellatrix, the Lion's Belt. And in the Lion's Belt, and in this part, we have famous nebula for the astrophotographers. We have Orion's Nebula. And over here is the Head Horse Nebula. But Orion is not alone. This hunter hunt together with a dog, and we have Canis Majoris constellation over here. So we have the back feet of the dog, and over here it will be the tail. We have the body of the dog, the front feet, and in this bright star we should have the head of the dog over here. This bright star is the brightest star in the sky at this part of the planet, and it's Sirius. So let's go to this part of the sky because I want to show you this object in the sky. I really like this, and these are our neighborhood galaxies that rotates around our own galaxy that we call it the Milky Way. And this one is the Small Magellanic Cloud and the Large Magellanic Cloud. And they are named after the circumnavigation of Fernando de Magallanes. He saw some strange object in the sky during the night that resembles a cloud. So they call it Small and Large Magellanic Cloud. I mean, he doesn't call it Magellanic, but in the history we call it Magellanic for his discoverment. But at that time they didn't know what a galaxy was. But now we know that a galaxy is a object with a lot of stars together. So all of the light that we can see are the light of the stars. And you can see in this part, these are irregular galaxies. We have seen the halo of the Small Magellanic Cloud, and in the Large Magellanic Cloud you can see a shape of a disc and like an arm. And in this part is another famous nebula. We have the Arachnic Nebula.
Tarantula?
It's a tarantula, right? We have the Tarantula Nebula. I knew that it was a spider. And it's a very very famous region also of star forming. And we have 30 Dorados star forming regions that forms stars so big that they thought back in 5 years ago that they were forming the stars a thousand times bigger than our sun, but they are too many stars actually. So another constellations that we have, for example, is Scorpio, but today I can't find the Scorpio. It should be over here. I don't remember. It has been a long time that I haven't done tours, and I forgot in these images. In clear sky, I can see with my own eyes, but in here we have a lot of stars that I kind of get lost in the pictures, but I can show you. Felipe, I thought you want to say something.
What you know? What part do you need to know?
Um, I was searching for Scorpio, but I will change it, and I will
Enter.
show you
This is Alpha
the.
Centauri.
Yeah. I know, because I will show you a part that I really like, and you can see here this star that is Alpha Centauri, and Alpha Centauri is not only one, but these are three stars together: Alpha, Beta, and Proxima Centauri. Being Proxima Centauri the closest star to our sun, only 3 light years of distance, and it's a system of three stars that are together rotating. And in this star, you can see the head of the llama, because the constellations of the people that live in the Andes mountain range, the Altiplanic, are known from. They are not from stars and joining stars with lines, imaginary lines. They observe the change in the colors and in the region in the sky. So you can see this black cloud over here. So we have the head of the llama, and the llama is the typical animal that lives in this part. So we have the neck, and we have the body of the llama, the back feet, and the front feet. And over here it will be the tail. And next to this llama, we have a tiny llama like a little baby. We have the head of the tiny llama, the ears, the the neck, the body and the feet. And it's like it's jumping alongside its mother. And also we have a serpent. It's so easy to find. You can see in this red part of the sky, and you can see some black clouds over here that resembles the shape and the movement of a serpent, and mostly of animals. But also, yeah, because we don't have much time, an important thing is to find the South Celestial Pole that I mentioned back in the 3.6 telescope. So when we focus our sight on this black cloud, you can see 1, 2, 3, and 4 bright stars, and these are known as the Croix, but we call it the Southern Croix because it's always pointing to the south, but the South Celestial Pole. So if we extend the major axis 3.5 times, let's go together, 1, 2, and 3.5. Over here should be the South Celestial Pole. Let's move over here, because another way to find the South Celestial Pole is with the 2 Magellanic Clouds. If you look closely with the small Magellanic Cloud, the large Magellanic Cloud, and if we try to make a triangle with all of the sides equal length, we should find the South Celestial Pole. And that means that all of the objects will be rotating around that imaginary point. So let's go through the platform over the 3.6 telescope. And you can see a yellow halo over here. And this is all of the light pollution coming from La Serena. La Serena, when Felipe and I live, and most of the other guys that are working right now at La Silla Observatory with people that go visiting La Silla itself. And you can see the road, the light pollution of the road, and from the next cities, the Vallenar, Copiapó, and also over here you can see the light pollutions coming from from Argentina, San Juan. And it's amazing. But we're almost we almost have no time left. So let's go to La Silla Hotel. And in this hotel is where all of the astronomers stays during the night of observations. It's not an hotel that you can pay. They are only for people that are working in here, and also the special visits, the operators that live outside, and it's so beautiful. And over here, we have the photographer that made possible this tour. And let's see the beautiful night sky. And I hope you enjoy this tour. It's so beautiful. And I hope you, if any question do you have that I don't in this tour you didn't ask us any too many questions, but I hope in the future you can ask us anything.
Whatever you want to need, in the next Saturday, we have a visit of the Paranal. And in the next Saturday, we have in Spanish visit of La Silla again. This is the same visit online, but you can ask different things about the astronomy, the telescope, or about the ESO, or whenever you want to know about the astronomy. But thank you to see us, and thank you to Pamela to showing the spectacular observatory. I like this. I like La Silla. This is the a museum of the astronomy. So you can visit us in La Silla. Wherever you want to know in the next Saturday, you can leave the question. And today, this is all. Um, bye bye, everything. Pame, you need to say something. The last
Not
word.
much, but thanks for watching us, and I hope you to see you in any tour. Let's say to virtual or presential tour. I hope you enjoy your visit.
To see ya.